Chapter 1. The Celestial Sphere. Cartesian and polar coordinates in space. Positional astronomy is the branch of astronomy concerned in determining the position of every kind of celestial objects. It is the most ancient and most important branch of astronomy. That is the reason why we start from this topic to study astronomy. We must first establish the fundamental elements of a reference system in space. Only after we have done that, we can establish a coordinate system to determine the object's position in space. Fundamental elements of a polar reference system in space: an origin point or pole cap O, an oriented direction or polar axis P passing through cap O, a fundamental half-plane F having as origin the polar axis P. The position of a point cap P in space is defined by three polar coordinates. The distance arc between the point cap P and the pole cap O, or the length of the ray vector, are outgoing from pole cap O towards point cap P. The convex plane angle U between the positive direction of the polar axis P and the ray vector R. The dihedral angle or attitude V between the fundamental half-plane F and the half-plane having the polar axis P as origin, passing through point cap P. The distance R is positive. The angle U is measured rotating around the pole cap O, the polar axis P towards the ray vector R. The angle U ranges from null to flat angle. The attitude V is measured rotating in a conventional versus around the polar axis P, the fundamental half-plane F towards the half-plane passing through point cap P. The attitude ranges from null to round angle. The polar coordinates of a point cap P in space range as follows: are greater than or equal to 0. 0 degrees less than or equal to U less than or equal to 180 degrees. 0 degrees less than or equal to V less than 360 degrees. The pole cap O is the only point in space for which R equals 0 and neither U nor V polar coordinates are defined. The polar coordinates are three independent parameters because the value of each coordinate does not depend on those of the other two. Particularly, the amplitudes of angles U and V do not depend on the value of R. Pole cap O apart, at each ordered triad open paren R, U, D close paren corresponds only one point P in space and vice versa. Fixing the distance R is like fixing the sphere centered at pole cap O on which point cap P is located. Fixing the value of angle U is like fixing the infinite cone with vertex at pole cap O and oriented as the polar axis on which point cap P is located. Fixing the value of attitude V is like fixing the half-plane with origin at polar axis P on which point cap P is located. Fixing the values of angle U and attitude V is like fixing the straight half-line with origin at pole cap O on which point cap P is located. Fixing the values of distance R and angle U is like fixing the circle centered on and perpendicular to the polar axis P on which point cap P is located. Fixing the values of distance R and attitude V is like fixing the half-circle centered at pole cap O having the diameter on the polar axis P on which point cap P is located. It may occur to deal with both coordinate systems. In this case, we usually assume the pole cap O as Cartesian origin cap O, the polar axis P as Cartesian axis C, the polar fundamental half-plane F as Cartesian half-plane X cap OZ with positive X values, the angle U as direction angle gamma, and the attitude V as plane angle between the oriented Cartesian axis X and the oriented cap P shortened distance direction. The cap P shortened distance is the distance between origin cap O and the orthogonal projection cap P prime of point cap P on X cap OY plane. It is oriented from cap O to cap P prime. The following change of coordinates rules hold. Polar to Cartesian. X equals our sine U, cosine V. Y equals our sine U, sine V. Z equals our cosine U. Cartesian to polar. R equals square root of x squared plus y squared plus z squared and square root. U equals inverse cosine of z over r. V equals open brace arc tan open second paren y over x, close second paren, x greater than 0, y greater than or equal to 0, pi over 2, x equals 0, y greater than 0, arctan open second paren y over x, close second paren plus pi, x less than 0, 3 pi over 2, x equals 0, y less than 0, arctan open second paren y over x, close second paren plus 2 pi, x greater than 0, y less than 0. Watch the video that illustrates this function.